We're going to be solving exponential equations again in Unit 9D. So we have solved problems like this. 2 to the x is equal to 32. We've learned that if we can rewrite both sides with the same base, that it is easy to solve. So this is 2 to the x, and then 32 is 2 to the fifth. If we get the same base, then we know that x then is equal to 5. So 2 to the fifth power is 32. However, in the second example, 2 to the x is 5. 5 cannot be written as 2 to a power that we know of anyway. All right, so since a logarithm is the inverse of an exponential equation, we can use logarithms to move a variable out of an exponent. So we can undo our equation and bring out the variable. So hint, if you're solving an equation that has a variable in the exponent, take the log of both sides. Now it doesn't matter what the base is, you can do any base, but we'll just do log, which would be base 10. All right, so example 2 says solve for the variable rounding the answer to 3 decimal places. Hint, isolate the exponential term first. Well, we'll start with the one that we were looking at. 2 to the x is equal to 5. This is isolated. There's nothing else over here with it. So I'm going to take the log of both sides. So the log of 2 to the x power is equal to the log of 5. All right, now we need to use that log property where if we have an exponent, the log of a number raised to a power, we're going to bring that x to the front. So this is now going to be x times log of 2 is equal to the log of 5. And whenever we have multiplication, to undo the multiplication, we will divide both sides by that. So log of 2 represents a number when we put it in the calculator. We're going to divide by log of 2 on both sides. So this will cancel, and this will end up being x is equal to log of 5 divided by log of 2. All right, so now we need to pull out our calculators and determine what the log of 5 divided by the log of 2 is. Now you can come over here and you can see the log right here on this left side. So I'm going to use this one's base 10. So that's the one we're going to use. It doesn't really matter which one I use. So I'm going to put, we're going to do fraction first. Let's do control and make a fraction. Then in the numerator, we want to have the log of 5. So I'm going to hit control, and here's log. And then, oh, it says, it gives me an option of doing a base. It doesn't really matter what we do. So let's just come up here and say, let's see if it'll do it anyway. Log of 5. And then come down here and again do log, and we're going to put log of 2, and let's just enter it and see if it complains. Now it didn't complain. So our answer then is 2.32193, which we're going to round to 3 decimal places. So that means looking at this fourth one, which is bigger than 5, I'm going to round up to 2.322. So we might experiment just a little bit and try substituting and checking it. So we get 2 raised to the 2.322. Oops, that's not 322, is it? 322 power, and enter it. And you see we get 10. Oh dear. Oh, I see what I did. Oh, you see I did 2 and 3.22. So let's do this again. So 2, whoops, raised to the 2.322, and that is 5. So B has a few more steps involved. So when you look at our exponential expression right here, 6 raised to the 3x power, you see that it's also over here with the 2 subtract. So I need to isolate this right here. So since the 2 is actually, I'm going to put is added right there, I'm going to subtract 2 from both sides. And that's going to leave me with negative 6 to the 3x is equal to negative 4.4. Then I have a negative, and I don't really want it negative, so I'm going to divide both sides by -1 and get 6 to the 3x power is equal to a positive 4.4. And now I'm going to go to my, well, now we need to get our variable out of the exponent, so I'm going to take the log of both sides. So remember, if you're solving an equation with a variable and an exponent, take the log of both sides. So I'm going to log 6 raised to the 3x and the log of 4.4. So the 3x is going to swing to the front, and I get 3x times log of 6 is equal to the log of 4.4. Now I'm going to divide both sides by the log of 6 so I can isolate my variable, and I get that 3x is equal to, and then we have over here the log of 4.4 divided by the log of 6. All right, so now what we're going to do is we're going to go to our calculator. We're going to put this into it and divide it and get an answer. So I'm going to get a decimal answer that looks something like this. And then once I get there, then I need to divide both sides by 3 to figure out what x equals to. All right, so let's do that on our calculators. All right, so there we have it, the log of 4.4 divided by the log of 6, and then enter, and I get 0.82, and then round that up to a 7. So 3x is equal to 0.827. Then we're going to take that answer, so we're going to do control and then answer, so get our answer, and then we want to divide it by 3, and then enter, and I get 0.27. So then x is equal to 0.28. It needs to round up. Oh, if I round it to 3 decimal places, that's wrong. If I round it to 3 decimal places, it's going to be 0.276 for our answer. All right, so here I have it where I've got it written. 3x is equal to 0.827. Divide both sides by 3, and I get x is equal to 0.276. All right, so at this point, why don't you come over and work D and E and then pick back up on the next video.